The second axis represents the amount of natural resources required to make goods. 0 denotes no natural resources, and as we follow the axis, more resources are used. The third axis represents the amount of knowledge used to produce goods. As we travel along the axis, more knowledge is used. What Chinchilninsky is uncovering is an interesting relationship between knowledge and productivity. For example, an economy that uses 5 units of natural resources for every unit of knowledge produces 4 units of goods. When more points are added, this economy will produce a cone that looks like this. However, an economy that uses the same amount of resources, 5 units, but more knowledge, will produce more goods. This economy has a cone that looks like this. What Chinchilninsky finds is a simple relationship. The more knowledge that an economy uses, the more productive it can be with its resources.
Knowledge has always been important for anything we did, but the movers and the shakers only felt contempt for people who traded in knowledge. And you might have heard the sentence, "If you are so smart, why aren't you rich?" Well, the situation has changed. The richest ones are the smartest. And it is understood now that it is knowledge which is attracting capital and is attracting money.
Knowledge. It can dramatically improve productivity and possibly lessen demand on natural resources. But Chinchilninsky has discovered that it's also doing something else, something unsettling. Knowledge may actually change the nature of world trade. Chinchilninsky developed this hypothesis using another set of cones called market cones. An economy like the United States, which relies on knowledge, has a market cone that looks like this. The cone is narrow, which means that there isn't a lot of fluctuation in the prices of this economy, and the economy is stable. An economy that relies heavily on natural resources has a market cone that looks like this. The cone is broad, which means the markets can fluctuate greatly. Countries in South America and Africa would have cones like this. When Chinchilninsky models several economies, she gets an array of market cones. The point of concern to Chinchilninsky is where the cones touch. Intersection marks the spot of common interests and values. Cones that overlap mean that countries trade. When cones don't touch, countries don't trade. Chinchilninsky's work suggests that knowledge-intensive economies will trade among themselves, leaving resource-based economies out of the loop. According to Chinchilninsky, many of the modern trading alliances and free trade agreements we see forming today are a result of this relationship.
Now, one concern, of course, is what this will mean for developing countries. Are we talking about a world in which the industrial economies, by the use of superior technology and advanced mathematics, will be moving faster and faster into a more productive future, leaving the developing countries, the agricultural society, further and further behind? The answer is perhaps. We don't know. So we are living through the shift now, through this change, and it's a bit scary. First of all, because although we know that something is changing, we don't know where we're going. Nobody knows where we're going. We haven't been there before.
Nobody can say for sure what will happen in the future. But by using mathematics, we can begin to gauge that we're in the midst of profound change. The information age is more than just a buzzword. In fact, it might be the next great era in human civilization.
I mean, many people believe that mathematics is boring and complicated. But in fact, these pictures of the cone show that mathematics can be beautiful and simple, and that some of the most interesting phenomena we're trying to explain here can be captured with our geometric intuition simply by observing these beautiful pictures.
In the past, humans have relied on mathematics to build the world in which we live. And today is no exception.
If so far you've been turned off by math, I would encourage people to sort of take a look at it from the point of view of whatever interests them, whatever hobby they have. Once I realized that this was a tool, it suddenly opened the whole world for me.
Mathematics is part of all of our lives, interwoven almost seamlessly into the fabric of the information age.
It seems like maybe people don't realize that mathematics is not dead. There are a lot of things about the world that we don't know, and it seems that maybe the only way we'll ever know them is through the application of mathematics.
To most people, mathematics makes the world more complicated. It doesn't do that. Mathematics makes the world more simple. Mathematicians are simplistic creatures. We look at the world in the simplest possible way. We look at it in such a simple way that the only way of capturing the simplicity is with symbols, lines, nodes, edges of graphs. We strip away the complexity.
Far from being a dry and boring subject, mathematics is a powerful tool we can use to create a new era, a new world that begins with our ability to imagine and dream.